All right, in our last section of Chapter 2, Lesson 6, we're asked to graph the following linear inequality. So, reviewing the protocol for this, we said the first thing was to change the inequality sign to an equal sign and solve the linear equation. Now, as we look at this, we notice 2 and 7 both divide evenly into 14. So we can use the intercepts for this one. The x and y intercept t-chart, where if x is 0, this will give us our y-intercept, and if y is 0, will give us our x-intercept. So let's do this. If x is 0 here, this is going to be a -2 as we divide both sides by 7. And if y is a 0, this is going to be a -7. So these are ordered pairs. And now we can change the equal sign back to the inequality sign. And we'll raise it up a little bit so we can graph this. So 0, -2. 0, -2 is right there. And -7, 0 is right there. Now, the next thing we have to decide is, are we using a solid line or a dotted line to mark our boundary of this inequality? Well, if it's only less than or greater than, we're using a dotted line. So this is only less than. So we'll use a dotted line here. I'll make a little dotted line here. And that's our borderline. Now we want to use a test point to see which part we're going to shade. And a common one often is the origin here, which is 0, 0. So let me put this in black here so we see the difference. So if x is a 0, this is a 0 here. If y is a 0, this is a 0. So basically we have 0 is less than -14. Now, is that true? No, 0 is greater. So this is not in the area of solution. So we're going to shade below. And again, when you do this, you get a bucket of paint slosh out. You had to pick out a dotted line and the bucket of paint. Now, using our other little technique too, I'm going to get rid of the zeros here. And looking at what we see here, this is a positive y. If you brought that x over and put it in slope-intercept form, it would be a positive y is less than. And we said when that is the case, we shade under the line. So we have two ways to solve this. Now, many of these examples are multi-step as well. And we're asked to graph these. Now, they're sort of interesting in that this one is in the form x equals a, which is a vertical line, and this one is in the form y equals b, which is a horizontal line. Now, in a sense, they're already solved. What type of line are we using? What boundary line? Are we using a dashed line for this or a solid line? Well, it's only an inequality sign, so we're going to use a dashed line. So it's at x is greater than -1. So I'm going to put like a little dash line here. This is not a solid line. This is just a dash line marking the boundary. Now, where is x greater? On the left or on the right? Well, the answer is on the right. So we're going to kind of shade this a little to indicate, and if you're doing this on your paper, lightly shade this area. This is the graph of this first inequality. Now this next one, and I'll use black for this, says y is greater or equal to a negative 2. So again, this is a horizontal line going through 2. And are we using a solid or a dotted line? Well, because if it's also equal, we're using a solid. So I'll take my line tool, and at negative 2, we'll put a nice solid line there. And I extended it so you could actually see it a little bit there. And here's this one, and this one. Okay, now where are we going to shade? It says y is greater. So is that above the y line or below it? It's above. So I'm going to kind of do this with black here. Now, what word describes these? Is it an and, which would be intersection, or is it an or, which would be union? Well, it's or, so it's union. So the graph then is everything that's included here. And while we're on here, if this were an and, then the only area would be where the two overlap, which would be up here. Now that's not what they're asking here, but that's a way to step by step follow to end up with the correct result. Okay, let's go on. Now in example 3, they're asking us to work with this absolute value inequality. Now my technical advisor did spot an error here, and I want to correct that, so I will do it. So we are asked to rewrite this as two linear inequalities. Now in this configuration, this is an and or an intersection. Keeping in mind the other was a, absolute value of a is greater than, whereas the greater than, this was an or a union. All right. So the protocol is to take away the absolute signs and just write it. 9x plus 7 is less than 4. And then you rewrite it again, and again, this is an and. 9x plus 7, reverse the inequality sign, is greater than a negative 4. And that's what I believe they want in this step. Now, to solve this, which is a two-step problem, we're going to go 9x is is less than, transpose the 7 on this side, it becomes a negative 7, and 4 gives you a negative 3. Divide both sides by 9, and you get x is less than a negative 1/3 when I simplified at 3/9. Now on this one, when we transpose the 7, it becomes a negative 7. And this is 9x is, we have to reverse the inequality sign, which is what we did already, would be greater than, on this side it's a negative 7, negative 4, negative 11. Divide both sides by 9 and we get x is greater than a negative 11/9. So if we were to graph this now, what would it look like? Well, the numbers we're interested in is a negative 1/3. And here a negative 11/9 would be there somewhere. And how do we graph this? Well, these are going to be a parenthesis. X is less than this, so a parenthesis at a negative 1/3 and going off in this direction to negative infinity. Now when we graph this one, X is greater than, and I'll use black for this, a negative 11/9. We're going to have a parenthesis there, and this goes off in this direction to positive infinity. But wait, we said this was an and is an intersection. So what would the answer in its graphic form look like? Well, it would only be the part where they're overlapping. So in a sense, a negative 11/9 to the 1/3. This would be the answer. In an interval notation, the parenthesis, negative 11/9, and then a negative 1/3, both with a parenthesis. Now, if this were a union, instead of what they're showing here, if the sign went this way, it would include everything, and that would be all real numbers from negative infinity to positive infinity. But again, that's why you need to be careful of what they're asking, these words and the symbols. Okay, let's go on. Example, this is also multi-step, but notice they are already solved for y. So it would just be a matter of graphing these as if they were equal and then choosing the correct line. So here our y-intercept is a negative 9. So that's right there. And the slope is 9/1. So it's over 1 up 9 right there. And then over 1 up 9 right there. And this is less than or equal to, so we're going to use a solid line. And looks like that. I'm off a little bit. Let me make it better here. Because there's not a lot of room on this one here. Perfect. Okay, now the next one, as we choose our line, and I'll use black for this. Well, before we do that, this is y is less than. So where are we going to shade? Now, actually, the under this line, if you pivot it, the under is this way. So we're going to shade this way here. And this one now is y is greater than this. And our y-intercept is at negative 4, which is right there. So over 1 up 4, over 1 up 4, over 1 up 4. Okay, and then this is a dotted line because this is only greater than, not equal to. So I'm just going to kind of sketch a dotted line here, going through these points. Okay, so again, this one is shaded, and I'll use blue here to kind of shade that here. Above the line, all this is shaded here. But remember, this is an and. So what is the area then of intersection? Well, it's a very, very thin slice. Only here. But not here, because this part ends there, and that would be the answer. Okay. Here, this is a rather easy one, I think. We get y plus 2 is less than a negative x. I'm going to take this 2 to the other side where it becomes a negative 2. And again, thinking of this as if it were equal, our y-intercept is on negative 2. So we put a dot right there. Our slope is a negative 1 over 1. So it'll be over 1, up 1, over 1, up 1, over 1. I'm just getting a few more points here. And do I use a solid line or a dotted line here? I use a dotted line here. Now, this one's easy. It says y is less than. Well, where is y less than? Above the line or below the line? And we're saying it's below the line. But remember, we can use the test point here. And a good one is the origin. So if y is 0 here, and x is 0, is 0 less than negative 2? No, 0 is greater than negative 2. Therefore, we shaded the correct region. The test point is not in the region of solution. All right, one more to go. For example 6, we have another inequality here, and I'm going to go to red because I like red. And they want us to write it in these two boxes. Now remember, this is a greater than, so this is a union, and it's also equal to, so would be a solid line, or in this case it's only one letter, it's going to be a bracket. But let's put it in its proper form here. Now this is similar to the one we did, again, except this is union. So this would be an or. So negative 9y plus 5 is greater than or equal to 45. Just take away the inequality or the absolute sign, and then now write the left part the same way. Negative 9y plus 5. Now reverse the inequality sign. This becomes less than or equal to a negative 45. So solving this side, it's negative 9y. We're going to transpose the positive 5 to this side, so this becomes a negative 5 on this side, so this is a 40. Now this is the tricky part, because we're going to divide an inequality by a negative. When we do that, to keep it true, we have to reverse this inequality sign. And this now becomes less than or equal to 40 divided by 9, a negative 9. So our answer here is y is less than or equal to a negative 49. All right, keep that in mind. Now in solving this one, I'm going to transpose the the positive 5 to this side where it becomes a negative 5. So this is negative 9y is less than or equal to a negative 50. This became a negative on this side, added it. Now I'm going to divide both sides by a negative 9. But again, since I'm dividing by a negative, I have to reverse that. This now becomes greater or equal, and this becomes a positive 50/9, and that is y. Okay, so let's put this on a graph. Put it up here. Got plenty of room. And again, this is multi-step, so we'll see what they're asking for. Now the negative 40/9 would go there, and then the positive 50/9 would go there. So what are the signs like? We're saying y is less than this, less than or equal to this. So we're going to use a bracket here, and this goes off to negative infinity. And this one, we're going to use a bracket going this way, and that goes off to positive infinity. And writing the answers in interval notation would be from negative infinity up to a negative 40/9 bracket, and then union, we had one like this before, bracket 50/9 comma to positive infinity. Okay, again, lots of stuff, and you'll be challenged as you do your practice and certify.